This is Cad Lesson number 5. We're going to shift gears a little bit today. Instead of talking about individual commands and things, we're going to do some production work to make ourselves useful. So this will be a pretty easy thing to start out with. We're going to open a file 2B325, and I'll just go ahead and browse for it. This is a site in Oak Ridge, and it's unfortunate because in the city of Oak Ridge they rotate all their plats and surveys about 34 degrees off of true north. So it really makes things a little wonky when you start surveying and plotting things out. I wish they were on true north, but that's the way things are. So to start with, we always have this image when we're working in a fresh file that I've imported from Google Earth about where our site is. This is oriented to true north and state plane coordinates. I'm going to attach an image of the actual plat of record. And I've got these options here when I select an image to specify the insertion point and the scale. So I'm just going to select a random point, click OK, scale it up at a random amount. Then I'm going to zoom in here, and I'm going to scale this to real world distances. So pick my scale point and a reference distance, and then I'm going to scale it up the plat distance, which is 132.5. This is not how I would normally start out. This is for illustration purposes for this video. Normally I would just read the plat directly on my desktop. I've got it in front of me, and I'm going to read the bearings and distances right off my desk. But for illustration purposes, we're going to go ahead and put this image in here. So we will just create a new layer, and we'll call it Oak Ridge Plat. Oh, it says it already exists. Well, let's go find it. So we'll make that current. So what I want to do is create bearings and distances and see how our lots close and build a mathematical model for us to go out and begin surveying. So I'm going to go up to my COGO menu up here, and then I'm going to use this command line by angle and distance. Pick a point number. I'm going to go over here and pick one of the corners on the image. Now it asks for a quadrant. And for some reason, these numbers are really hard to read. The letters, some of them look like they're missing, but I can tell that this bearing goes southeast on this northerly line of lot 103. So I'm going to go enter a 2 for the southeast quadrant. And then I'm going to enter a bearing of 49.03. Not 0.3, but 03, because that's 49 degrees 3 minutes. It appears to be. It may not be, but that's our best guess since the plat is so illegible. And then a distance of 200.5. And that appears to be correct because it's traced right on top of our plat. Then I'm going to go right here, south 45 degrees. Looks like It could be 53 minutes west. Hard to read. That's the third quadrant, southwest. My bearing angle is 45, 53, let's say 23 feet. Right here, 23.0. That looks close. Then we're going to go northwest, which is quadrant 4, 7904, 200 feet. And then we'll see if we can close it. Quadrant 1, 29 degrees, 22 minutes, 132.5. It doesn't quite close, so we've got something wrong. Looks like there's an extra distance in another corner here. Another 7 feet that I missed, looks like, right here. So we're just going to take these lines, use the move command, and select all these. Then I'm going to move, hit F3 to turn my snaps on. Move that over there. So let's put another little line segment in there. Click here as my starting point, quadrant 1, 45, 53, 7 feet. And that tells us about how our lock closes. And it's in the ballpark, not perfect. Looks like we got an error of closure of 1.87 feet. Not terribly unusual, not particularly desirable. But let's go from here. This is what we've got to work with. So we'll now enter the bearings and distances on lot 102 up here. COGO menu, line by angle distance, pick my starting point. I've got a northeast bearing, that's quadrant 1. A bearing of 6 degrees, 0.27, 6 degrees, 27 minutes. A distance of 186 looks like. Okay, that can't be 6 degrees in that far into that quadrant. That's what 6 degrees looks like, is where it drew that line. So let's try that again. Quadrant 1, let's try 60 degrees, 27 minutes as a best guess. 186. Okay, that can't be 186 feet either. So they've got some erroneous information, looks like, on the plat. Let's pick it and see about what it scales. If I do a distance from this point to this point, I get 116, about 117. Let's go back here and start on the other side. Quadrant 1, 45, 53, 34 feet. Okay, now let's go in the northwest quadrant. Since that's a southeast bearing, we're going to go the back bearing, which is northwest. It's quadrant 4. 24 degrees even, 58 feet. That's about correct. So we'll keep that bearing code 4 and keep the bearing 24 degrees and a distance of 203. So that can't be 203 feet. Perhaps the total is 203 feet. None of that works. So we're just going to hold the direction since part of it seems to be working, and I'm going to trim that. In this case, it's really good that we put this image in here because it's very helpful to see how this is coming out since nothing seems to be working. So if I list the distance now that we've trimmed it, I get 123. Let's try lot 101 up here. That'll be the northeast quadrant. 88 degrees, 49 minutes, 90 feet. That doesn't seem to particularly work either, but let's continue. Now we want to go this bearing and distance, which we don't have. It's a radius. So let's start on the other side. Northeast quadrant, 46 degrees, 35 minutes, 45 feet. Okay, that looks like that is working about right. Keep the same quadrant, same bearing, 83.4 feet. That's about correct. Let's continue from up here on lot 100. Quadrant 1, 3 degrees, 50 minutes, a distance of 173.3. That's about correct. Southeast, quadrant 2, 4002, 98 feet. That's not working. Perhaps it's 198. Sounds plausible. I'm going to draw a circle with a radius of 198 at that point and extend it. So there's a good bit of trial and error here to see what works. Perhaps this one should be 190. Let's try that. Nope. So let's just arbitrarily trace this. We'll go this, drag this direction parallel with that line and just call it 27.3. Drag this direction parallel with this line and call it 33.6. Certainly not the best way to do things, but it should get us in a ballpark for looking for something, and that's what we want. We want good points to be able to investigate and find things in the field as we need to. So let's come down here and start at lot 104. Quadrant 2, 1803, 194.7. That appears to be correct. Quadrant 1, 4533, 200.1. That appears to be correct. Quadrant 4, 4427. I think that says 22, which does not scale correctly. It does not really work. So we're just going to trim this off because it does seem to intersect that sideline at 200 feet. So this is very much a trial and error process, and I'm really surprised at how poorly this particular plat is working. Oak Ridge can be a little hit or miss. Generally, the surveying is pretty good. So let's put in another couple of lots. We don't seem, oh, here we go. Quadrant 2, and apparently at a bearing of 43 degrees even, perhaps 62 feet. Do it again, go another, well, that distance is illegible. This is the actual plat, cabinet, and slide. As it happens, I've got archival maps for the city of Oak Ridge. So let's see what happens if I pull a map out of the archives. We're on map 14BX. Which is right here. See if this is any clearer and gives us more information. And this is just something that I happen to have, being in the area for years, acquiring things over the years. And this map definitely seems to be clearer. Much clearer. So I think we're going to use this map out of our archives instead. From my PDF. Call it plat from archive. I'm going to move this one over. It's just arbitrary coordinates anyway. And attach the other image and see how this works. We'll try it again. Move over. Scale the image. I'm going to send that to the back. My draw order command. Scale it. Now we see some differences. This offset right here is not on this other plat. And that could be part of the culprit. It seems I would trust this more than the one referenced in the deed. It looks like. So I think we need to start over a little bit. Let me check my bearings, see if it matches. 1803. I feel like we just need to start over because I don't know what is good and what is bad at this point. So I want to move this over here and we're going to start from scratch. We'll draw 103 first. Quadrant 1, 29, 22, 132.5. Let's go to this northerly line of lot 103 next. Quadrant 2, 4931, 200.5. Quadrant 3, south 45 degrees, 33 minutes west, 23 feet. Quadrant 4, 79, 41, 200.1. Still not closing, but we're... Oh, again, I forgot the 7 feet. So we'll just move these lines. Quadrant 1, 4533, 7 feet. Much better than what we had before. So let's continue. Quadrant 1, accept that. Accept the bearing, 4533, 34 feet. Quadrant 4, 2401, 58.1. Keep the quadrant, keep the bearing, 120.3. Now southwest, quadrant 3, 6127, 118.6. So these lots don't close great, and it's a little subjective about how we do our adjustments to make it work. But I would probably move this up here, call this good, rotate to it to build my lots. I'm going to copy this over here to keep its integrity in case I want it later. Okay, now we're going to go build another lot. 101. Quadrant 1. 8849. 119. Again, we don't have any bearing information, so we've got to go somewhere else. Let's go up here. Quadrant 1, 4635, 45.2. Quadrant 1 again, same bearing, 83.4. Then we'll just draw a line from here to here. Now I'm going to list it and see how close it is to 33.6. 34.12, not close. But hopefully when we get out in the field, we'll be finding monuments that help us to tighten things up. We're going to honor the monuments that we find. So let's build 104 down here now. Quadrant 2, 1831, 179.7. We'll go ahead and draw that little 15-foot segment, keep the quadrant, keep the bearing, 15 feet. I'll go ahead and go from here southeast, 4311, 61.2. The fact that there's a monument there suggests to me that there might be a bearing change along this line that I'm not given the bearing on there. But we'll continue and see what happens. Keep the quadrant, keep the bearing, 61.1. again, go another 45, and again go another 12.8. Now let's go back up here on the south side of lot 104. Quadrant 1, 51 degrees even, 194.42. Quadrant 4, 44.27, 17.2. Good thing I had that drawing in the archives. Now we'll go to the other side of that lot. Quadrant 2, 44.27. Looks like 69.1. Let's move to the south side of that lot. Quadrant 1, 40.05, 204.8. Modern plats generally work much better than what we're given here. But this is a puzzle. And this is a lot of times just what we have to deal with. So I'm creating a mathematical model for us to put in our data collector, and this will help us to start looking for corners. And what I generally do when I've got enough information is I will move this over to our Google Earth image. And I'll compare it to my GIS information. And I know that we're going to have to rotate about 34 degrees. It actually says on the plat of Oak Ridge, 34 degrees, 13 minutes. So we'll just rotate that much and then slide things around, because I know we're on this road here. And this is about where we start looking. Something like this. Probably need to move this around a little more. And that gives us a starting point. And I could continue to build more lots to look for more corners in case we needed them to back ourselves up. But you get the general idea. Now, in the case of deeds, I'm going to find a deed image, just a random deed image. I'm just going to go to a directory where I know that I've saved a deed. Select it and insert it so we can look at it. So what we have is a deed description, and it gives us a description to a beginning point. And then once we get the beginning point, we have a series of bearings and distances. And we're just going to do the very same thing that we did when we had the plat. There's a bearing and distance, and it tells you what your monument is. Here's another. And so on. They generally go in a clockwise direction, but not always. And we would plot this deed up just by entering the bearings and distances, just as we did on the plat, consecutively, one after another. And ideally, this description would close on itself perfectly. Much of the time, the deeds don't close. Sometimes they close pretty well. These are to the nearest minute. A lot of more modern deeds have distances, bearings to the nearest second. So I would not expect this deed to close anywhere near perfectly, but hopefully we're going to be in the ballpark when we come back around to the point of beginning. So I'm not going to plot this up for you, but just realize you're using all the same commands to generate this description. Now, if you get to a curve and it gives a radius and so forth, we just ignore those, because a lot of times you're dealing with non-tangential curves. What you're looking for is the chord bearing and chord distance, and that is what we're going to plot and see if the deed closes. So I'm going to end this one here and let you practice on this.